Here are 5 exponential and logarithmic questions you are almost guaranteed to see on your Algebra 2 final exam. No chit-chat, we're just doing the math. Let's go. Rewrite in exponential form. Right now it's in logarithmic form. We're taking this a, which is the base, and then you are going to be raising it to the 12th power, and the answer is this b. If we do another one real quick, just to make it clear, the base is 3, the exponent is 7, and the answer is x. Condensed to a single logarithm. Well, the log properties say that if you are subtracting two things that have the same base, that the things needed to be divided at some point. Adding means that they were multiplied. When you see a number in front of a log, that used to be an exponent on the answer part. So the first thing we're going to do is put these numbers that are in the front, we're going to put them back up where they started. So the 8 goes up on the 6 as an exponent, the 5 goes up on the 11 as an exponent, and the 4 goes up on the 7 as an exponent. All have base 3, that's important. Now, if you have two things that have the same base that are being subtracted, that means these things were being divided initially. So we have log base 3 of 6 to the 8th power over 11 to the 5th. And that is being still added to log base 3 of 7 to the 4th power. This is a plus. According to the log properties, these things were being multiplied together. So we have log base 3 of 7 to the 4th power times the fraction 6 to the 8th over 11 to the 5th. I'm not going to multiply that stuff out. I'm just going to bring the 7 to the 4th up. So this is the final form. Put a box on it. Moving on. We need to solve this equation for e raised to this power minus 2 equals 5. So let's isolate this exponential by adding 2 to both sides. 2 plus 5 is 7. Now I'm going to divide both sides by the 4. Because this is base e and you're trying to get at a variable that is in the exponent, you need to use logarithms on both sides. But base e means you have to use the natural log. Once you apply a natural log, you can bring the exponent down. This 7n minus 9 is going to come down in front. Natural log of e equals 1. So now we're going to add 9 to both sides and divide by 7. This is the final answer. That was question 3. And if you are cramming last minute for your final, this is part of a video series. The full playlist is in the description. Let's do the next question. The first thing I see is everything is in base 9, which makes this a little problem easier. Since that's subtraction, I know that this is x divided by x plus 4. It's like that problem we just did that was expanded and we're condensing it. Now, here's the thing that's interesting. If you have the same log on both sides and these two things are equal to each other, it means these things you're taking the log of have to be equal to each other. Let's multiply both sides by x plus 4 to get rid of this fraction. We get x equals 63 times x plus 4. Multiply the 63 through and subtract it, and we end up with x equal to a really crappy number, which is negative 4.06. And you might think that's an okay answer, but it's really no. And here's why. The domain of logarithms, the x's that you put in here, all have to be positive. There's no way you can have a negative x. You can check that with your graphing calculator, but when you're working with log functions, domain is greater than 0. So that means this problem actually has no solution. The employee receives a 3% raise once per year. If the employee's initial salary is $62,600, what will be the employee's salary after 9 years? This is a pretty basic compound interest problem. Here's the formula for that. Amount equals principal times 1 plus rate raised to the power of the time. The 3% is your rate. The initial salary is your principal. Your time is 9 years. So let's just plug all those numbers in. So now we grab the calculator, crunch the numbers, and that will be their new salary after 9 years if they get a 3% raise every year. Exponentials and logarithms are done. You are one step closer to passing your Algebra 2 final. If you need to master trig next, which not every Algebra 2 teacher does, but if yours did do trig, here's that video waiting for you. Go crush your final.